I was a high school chemistry teacher for 3 years, and I have more biochemistry background after that, so I'd like to speak to this. When the alum hits the lake, it's no longer there. The alum forms a hydroxide, aluminum hydroxide. So alum is a salt, it's aluminum sulfate. It has two halves, an aluminum +3 ion and a sulfate ion. They go in, they dissolve like table salt will dissolve in water. And so you no longer have the alum. The aluminum +3 reacts with the water and forms aluminum hydroxide. That's the white flock that you see during an alum treatment. Aluminum hydroxide is present in antacids. It's present in baking soda. It's present in a lot of products that you may have used over the years. It is totally harmless, obviously, if it's in an antacid. The aluminum hydroxide settles to the bottom. That's what Ed has been talking about, that resides down there. And that protects the phosphate from harming the lake. And aluminum hydroxide then is what you're talking about being there forever. But it's not going to be there forever. As the aluminum reacts with the phosphate, excess phosphate, you're going to get aluminum phosphate, and that will be there forever, perhaps. Over time, it's a very insoluble salt. It's bound up, it's sequestered, it's not going anywhere. But over eons, if you want to look ahead, there will be solubility and it will flush out with the groundwater eventually, but that'll take, obviously, a long time. So why are we having to use alum? It's because normally what the process is in a healthy lake, and what happened before all of this happened, was iron was doing the job that alum is doing. Iron is a +3 ion when there's oxygen at the bottom of the lake. And iron +3 will bind the phosphate, and that's what happens normally in a healthy lake. But when there's anoxic conditions like we are getting in our lakes now, because over the years we've been adding this phosphate and other nitrogen nutrients, the algae have been growing and making a sediment that now has bound up all this phosphate, and it's there. And every once in a while it comes out and stimulates a cyanobacteria bloom. And that's what we're all talking about. But the cyanobacteria bloom is the tip of the iceberg. What's worse is what's underneath, which is all eutrophication that's taking place in the lake. And when we measure oxygen levels and we go down, especially in summertime, they go down to near zero. And the lake is not healthy. It's not healthy all the time, not just when these cyanobacteria blooms happen. And so we need these treatments now to restore their health and prevent this eutrophication from going on. Now, when the sewers are here, that'll be great. That'll prevent more phosphate from going in, and we can wait for a natural process to restore the lakes. But until then, the only relief these lakes are going to get is if they take their medicine, and the medicine in this time is the alum. And we all don't want chemicals going into our bodies, but we take medicine when we're sick. And the lake is sick, and it needs its medicine. So please, please support the alum.